let's review dt and vt graphs. Now, you'll have done a little bit of this in probably level 1 science or level 1 physics, and we have graphs where we have time on the horizontal axis, distance on that axis. If it's displacement, it needs to have direction, and a simple displacement time graph could be just the positive and negative axes, right? So, but when you're looking at a physical situation, you need to define your axes, which might be up is positive, down is negative, right is positive, left is negative, something like that. But that would be two-dimensional. This graph is only showing you one-dimensional, but with two directions. So the dt graph, I think you're aware that a straight line on a dt graph, constant rate of change of distance with time, is a constant velocity. And I think you probably remembered that a steeper line, straight line, is a constant velocity, but it's a bigger velocity because it's a bigger rate of distance with time. Now, what about curves? Well, with curves, if the gradient's getting bigger, then that velocity is changing and it's increasing. So we would call that an acceleration. This is still on a dt graph. Remember the graph where we had that type of curve? The gradient starts off fast. Well, it starts off high, which indicates a fast speed, but it gets less and less. That's a deceleration. Now things do get tricky, and we will get to the tricky bits, don't you worry. But first we need to have a look at VT graphs. Now with VT graphs, there were a couple of things we needed to remember. Again, you could have positive and negative velocity, maybe up is positive, negative. If positive displacement is up and negative is down, then a positive velocity means that you're going in the positive direction, right? Up, if that's the way you rated it. Now on a VT graph, a horizontal line was a constant speed, whereas a constant slope was a constant acceleration. Right? Whereas a curve like that, that's a changing acceleration. Alright? Now the thing to remember also about these VT graphs was that area under a VT graph represents displacement. So we've got these formulas, V equals D over T. So V times T equals D. Right? Now that means that the area, V times T, is the area which is your displacement. So if you had a graph that went something like this, and that was positive velocity and that was negative and the middle was 0, then this is positive displacement and this is negative displacement. So this was going positive direction, this was going negative direction. But the area represented how far they went in a positive direction, so therefore the negative area is smaller than the positive. Therefore they went a certain distance positive and then they came back a bit, but they're still a positive distance away. So you needed to figure that out with your VT graphs. Now, we've looked at the acceleration. Sorry, let's get back to this one. Acceleration was the slope. So the gradient represented the acceleration. And the area represented the displacement. Now, we have some issues when we look at graphs. Let's draw one. VT graph again. We've got a positive there, maybe like that. Seal this hopefully. Alright, now let's look at this graph. This is a VT graph. Constant speed, right? Now we've got a positive gradient, therefore that's a positive acceleration. A positive acceleration and a positive velocity means you're accelerating in the positive direction. Whereas we've now got a constant speed, but then we've got a negative gradient. When we've got a negative gradient, we've got a negative acceleration, but we still had a positive speed or positive velocity. So that means the thing is still going, it's still got a speed in the positive direction. That means it's going in the positive direction. But because it's got a negative acceleration, that means it's slowing down. This is the tricky bit, and you might have to think about that a few times. This bit here is still a negative acceleration. If you're not aware yet, when I just put a negative or a subtraction sign next to VE, that means negative. If I just put a plus next to VE, it means positive. So down here we've got a negative gradient. That means a negative acceleration, but we've got a negative speed. That means it's going. The speed tells you what direction it's going in. The acceleration, if it's the same sign as the velocity, then it's speeding up in that direction. If it's the opposite sign, then it's slowing down in that direction. Alright? You must have to think about that a few times. Alright? So this is negative velocity and negative acceleration. Alright? That means it's speeding up in the negative direction. Velocity tells you what direction it's going in. Acceleration tells you whether it's speeding up or slowing down. If it's speeding up, it's got the same sign, negative and negative, as the velocity. The acceleration and velocity have the same sign if it's speeding up. If they've got opposite, then it's slowing down. Now here, we've got a positive acceleration and a negative velocity. Negative velocity means it's still going in the negative direction. Positive acceleration means it's slowing down, but it's still going in the negative direction. When it gets back past here, positive acceleration and positive velocity, speeding up in the positive direction. Right? Let me just give you another example to further clarify that. Big field, kick my soccer ball, big kick. When I kick, it immediately has a velocity. Right? After that, there's only one force acting, gravity. So here, 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 here. Gravity, 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 all the same. Gravity is the force, weight force. That's the force acting on the ball. It's constant. Gravity doesn't change, the mass doesn't change. So the acceleration doesn't change. The acceleration is constant the whole time. And if you had called down negative, so down is negative and up is positive, right? If you call down negative, up positive, then the acceleration stays positive, down stays negative the whole time. But the velocity, which is at different angles the whole way through, has different components. Its horizontal component stays the same, but its vertical component going up is up. So its velocity, if I just draw the vertical component of the velocity, then here, like that, slowly getting smaller until it's zero. So the velocity is getting smaller, the vertical velocity. The acceleration stays the same, but they're in opposite directions, aren't they? Positive velocity and negative acceleration. But once it gets past that top bit, the velocity starts to go in the negative direction. Negative acceleration, negative velocity means it's speeding up in the direction it's going in. They were round the other way in this example. I think it's enough on that.